Hello everyone. This video will go over solving rational equations. Okay, so first we're going to go over the steps. First step is to factor all numerators and denominators if necessary, which means that if it's already factored out as far as it can go, you can skip the first step. Okay, on the second step, you want to find the least common denominator to make sure all denominators are the same on both sides of the equal sign. Okay, this will allow us to get rid of all the denominators or basically eliminate the fractions. Okay, now our third step, remove any grouping symbols. So parentheses, you want to go ahead and use distributing to get rid of those, and then we can go ahead and solve the equation. Okay, now your fourth step is you want to check your solutions, because it is possible you can have more than one solution. Okay, so as soon as you get more than one solution, you have to check to make sure that if you plug in any of those solutions, your denominator will not equal 0. All right, so if you're still writing, please feel free to press pause. But we're going to go ahead and go to our first example. All right, so let's say, for example, we want to solve x over 6 plus 4x over 3 equals x over 18. Okay, so remember the difference between an expression and an equation is that equal sign. If you have an equal sign, you have an equation. If you don't have an equal sign, you have an expression. All right, so for this one, we'll go to our first step. And most of your numerators are already as factored as you need them to be. Your denominator, you can factor if you want to. So if you have x over 6 plus 4x over 3, you can make that equal x. 18 is 6 times 3, so you can make that 6 times 3. There. Now you don't have to do that, but it's just a way you can go. All right, let me move this over a little bit because we're going to kind of tweak this a little. Okay, so remember, you want all of your denominators to match. So if you have x over 6 plus 4x over 3, give it a little space, equals x over 6 times 3. You have a 6 here, a 6 here, but you don't have a 6 here. Okay, so in order for them to match, you have to put a 6 there. So you multiply this denominator by 6, but whatever you do to the denominator, you have to do it to the numerator. Okay, so you have a 3 here, a 3 here, but you don't have a 3 here. So you have to multiply that denominator by 3, which means you have to do the same thing to the numerator. Okay, so now all of your denominators match. You have 3 times 6, 3 times 6, 3 times 6. So now you can go ahead and multiply your numerator. So you have 3 times x, which is 3x, over 3 times 6, which is 18, plus 4x times 6x, well, times 6 is 24x. So you have 24x over 18 equals x over 18. Okay, and the reason this is important because now, as long as all of your denominators are the same, you just multiply each term by that denominator. which in this case is 18. So if you multiply this term by 18, and you multiply this term by 18, we'll move that there out the way, and you multiply this term by 18, these 18s will now cancel each other out, where it's just 1. Which will give you 3x plus 24x equals x. All right, so now we can go to our third step and just solve. Okay, so if we go ahead and combine those two, you have 24x plus 3x is 27x. So 27x equals x. So if we subtract x from both sides here, we have 26x equals 0. And as soon as we divide both sides by 26, we have x equals 0. Okay? But now we have to double check for our fourth step. We just want to make sure, and you can kind of do this in your head. You don't have to write this down. So you have x over 6 plus 4x over 3 equals x over 18. X equals 0 will not cause any of those denominators to equal 0. So x equals 0 will not cause a denominator to equal 0. So it's a valid solution. Okay, so x equals 0 is a valid solution. Okay, so there are some cases where if you plug it in, you will end up with a denominator of 0, which means you won't be able to use that solution. All right, so let's go ahead to our next example. All right, so let's say, for example, if we wanted to solve 1 over x plus 2 equals 4 over x squared minus 4 minus 1 over x minus 2. All right, so remember our first step is we're going to factor all of our numerators and denominators if necessary. Let's clean up that 1 a little bit so it looks more like a 1. There we go. Okay, so really all of these denominators and numerators are about as factored as they're going to get. The only one that you can factor is the x squared minus 4. Okay, and if you remember, x squared minus 4, you can rewrite that as x squared minus 2 squared because it's a difference of squares. Okay, so difference of squares, this becomes x plus 2 times x minus 2. Okay, so if we go ahead and we rewrite this as 1 over x plus 2 equals 4 over x plus 2 x minus 2. That's all we did was factor that one. Minus 1 over x minus 2. Okay, so now we go to our second step where we match up our denominators, which if you wanted to, you could go ahead and do it in this step. I'm just kind of breaking it down. Okay, when you do it and you're used to it and you're comfortable with it, you'll do a lot of these all in a lot shorter time. Okay, so if we have 1 over x plus 2 equals 4 over x plus 2 times x minus 2 minus 1 over x minus 2. Go ahead and put that in parentheses up there. We can see here we have an x plus 2 here and an x plus 2 here, but this one's missing the x plus 2. So we can go ahead and multiply this denominator by x plus 2, but we have to do the same thing to the numerator. Okay, so we have x plus 2, x plus 2, x plus 2. Now this one has an x minus 2, this one has an x minus 2, but we're missing the x minus 2 here. So we multiply this denominator by x minus 2, but we have to do the same thing to the numerator. All right, so we can go ahead and start to simplify this. Actually, we can go ahead and go to our next step here. So we have x minus 2 times 1, which is x minus 2, over x plus 2 times x minus 2 equals 4 over x plus 2 times x minus 2. I'm going to give it a little bit of space because we're going to do some more canceling out. So you have 1 times x plus 2, which is x plus 2 over x plus 2 times x minus 2. Okay, and the reason I gave it a little bit of space is because when you multiply each term by x plus 2, x minus 2, they're going to cancel out. Now, you don't have to actually do this part if you don't want to. I'm just showing you that as soon as all of your denominators match, they're all going to cancel out. Okay, so if you multiply this one by x plus 2 times x minus 2 over 1, and this one by x plus 2 x minus 2 over 1, you multiply this one by x plus 2 times x minus 2 over 1, then you'll see that this x plus 2 cancels out with that one. Same with the x minus 2, same with the x plus 2, same with the x minus 2, x plus 2, and the x minus 2. Those all cancel each other out. As long as you do the same thing to both sides of the equal sign, you're okay. So that just leaves 4 times x minus 2 is the only thing that didn't cancel out, equals 4, because everything else canceled out in that one. So you have 4 minus x plus 2. Don't forget that minus sign, so you want to have your parentheses. Okay, that's a really easy mistake to make. All right, so you go ahead and write to your third step and you solve it. The reason that parentheses is important because that minus applies to that whole numerator. Okay, so we go ahead and we distribute to simplify it. So we have 4 times x, which is 4x. 4 times negative 2 is negative 8, equals 4 minus, once we go ahead and distribute that negative, negative 1 times x is negative x. And negative 1 times 2 is negative 2. Okay, so now we can go ahead and start combining like terms and moving variable terms. So if we go ahead and combine those two, move that up a little bit, we have 4x minus 8 equals 4 minus 2 is 2. So you have 2 minus x. All right. Oh, made an error. It should be a 1 there. My mistake. I don't know why I put the... Glad I caught that because it would have given us a wrong answer. Sorry about that. So that should just be 1x. I know a couple of you were probably yelling, no, you made a mistake. You made a mistake. Okay, I heard you. Well, I may not have heard you, but I felt your presence. There we go. Okay. I usually catch my mistakes pretty quick. So, all right, so we're going to go ahead and still combine those two. So I have x minus 2 equals 2 minus x. All right, so if we go ahead and add x to both sides, then that gives you 2x minus 2 equals 2. If we add 2 to both sides, then that gives us, move this up a little bit, 2x, as that cancels out, equals 4. So as soon as we divide both sides by 2, we end up with x equals 2. All right, now remember, we still have our fourth step. Okay, so if we have our fourth step, we know that 1 over x plus 2 equals 4. And instead of x squared minus 4, I'm just going to make it x plus 2, x minus 2, minus 1 over x minus 2. And you'll see here that if you plug in x equals 2, you will get a denominator of 0 here and a denominator of 0 there. It doesn't have to be all denominators of 0. If you have just one denominator of 0, you cannot use that solution. Okay, so plugging in x equals 2 will cause a denominator of 0. Okay, so that means you cannot use x equals 2. And since you can't use x equals 2, because it's not a valid solution, that means your answer is actually no solution. Because the one answer you did get, you can't use. All right. Other than that little mistake there, hopefully it all made sense. Okay, so we're going to go ahead and go to our next example. All right, let's go ahead and bring this on down. Okay, so let's say, for example, we want to solve 5 plus 4 over x equals 1. All right, so with these problems, whenever you have just whole numbers, those are actually the easiest problems to do because the amount of work you have to do is just cut down by a lot. Okay, so we're going to go ahead and I'll show you what I mean by that. Okay, so first of all, we can skip the first step because you don't really need to factor anything. Okay, so no factoring necessary. So we can go ahead and skip that first step. Now for your second step, you want to match your denominators. So to do that, you just have to remember that 5, you can make that 5x over x. Exact same thing. And also 1, you can make that x over x, because as soon as you cancel out the x's here, you're left with 5. As soon as you cancel out the x's here, you're left with 1. Okay, so that's why this is a lot easier, because as soon as you are given a whole number, you can make it whatever denominator you want. Okay, so if you had an x plus 1 here, you can make it 5 times the whole quantity of x plus 1 over x plus 1. Same thing here. If you wanted to make it x plus 1 over x plus 1, you could. So these two can be whatever you need them to be. You just have to do the same thing to the numerator and denominator, and you're set. All right, so we're going to go ahead and replace the 5 with 5x over x. So we have 5x over x plus 4 over x equals x over x. Okay, so just like before, we already know as long as we have all of our denominators the same on both sides of the equal sign, they will cancel out as soon as we multiply each term by that same value. So if we multiply this term by x, this term by x, and this term by x, these two will cancel each other out. These two will cancel each other out, and these two will cancel each other out. So you will be left with 5x plus 4 equals x. Okay, which brings us to our third step, which is just to solve. Bring that up a little bit. All right, so if we go ahead and subtract x from both sides, 5x minus x is 4x. So we have 4x plus 4 equals 0. Okay, so now we just go ahead and subtract 4 from both sides. So we have 4x equals 0 minus 4 is negative 4. So now as soon as we divide both sides by 4, anything divided by itself is 1, we will have x equals negative 4 divided by 4, which is negative 1. Okay, now remember, you still have one more step. And that's where a lot of mistakes are made. So you want to respect that last step. So you have 5 over x, or 5x over x, plus 4 over x equals x over x. If you plug in negative 1 for any of those x's, it does not turn the denominator into 0. So you are okay. And again, you don't have to write this step down. You can just kind of look up and see whether you are here or here. So you don't have to write this step down if you don't want to. All right, so from there we are going to go ahead and verify that this is a valid solution. So plugging in x equals negative 1 will not cause any denominators to equal 0. Okay, so that means this is actually a valid solution. Okay, so we are good there. All right, so we are going to go ahead to our next example. All right, so let's say, for example, if we wanted to solve the equation 3 over x plus 3 equals 12x plus 19 over x squared plus 7x plus 12 minus 5 over x plus 4. Okay, so what I want you to do is go ahead and press pause and give this one a try for yourself. All right, so I'm assuming you've pressed pause, you've worked this one out, and everything looks good, and you're ready for me to just verify that you are correct. Okay, so remember your first step is to factor whatever is necessary. Okay, so you have 3 over x plus 3, can't really be factored anymore, so we can leave that the way it is. 3 over x plus 3 equals 12x plus 19. There's nothing in 12 and 19 that could factor out, so we can write that the way it is. Okay. Now x squared plus 7x plus 12, you can actually factor that into x plus 4 times x plus 3. And 5 over x minus 4, that's pretty much the same. You don't really have to change that. So you have 5 over x minus 4. And just a little side note that x squared plus 7x plus 12, x plus 4, x plus 3. All right, so it brings us to our second step, which means we have to match our denominators. Okay, so I'm going to go ahead and rewrite those with a little bit of space. We have 3 over x plus 3 equals 12x plus 19 over x plus 4 times x plus 3 minus 5 over x minus 4. Okay, so I just left a little bit of space here and here because that's where we're going to have to make our changes. Okay, so you have an x plus 3 here, an x plus 3 here, but we don't have an x plus 3 here. So we have to multiply our denominator by x plus 3. And whatever we do with the denominator, we have to do it at the numerator. So we multiply that one by x plus 3. Okay, so we have x plus 3, x plus 3, x plus 3. So we're good with that one. We also have an x minus 4 here. Oh, x plus 4. Sorry about that. Don't know why I did that. So we have an x plus 4 here and x plus 4 here. So we're missing an x plus 4 here. So we multiply this one by x plus 4 and x plus 4 here also. Okay, so just as we've seen through the previous couple of examples, when the denominator is the same on both sides of the equal sign, they will eventually cancel each other out if you multiply all terms by x plus 4 times x plus 3. And why did I put that up there? Okay, here we go. Okay, so we have 3 times x plus 4 equals 12x plus 19. That's positive, so we don't really need parentheses around that one. Minus 5 times x plus 3. All right, which pretty much brings us to our next step, which is to solve. So we go ahead and distribute our 3. And go ahead and distribute our negative 5. Okay, so 3 times x gives us 3x. And 3 times 4 gives us 12. Equals 12x plus 19. And if we go ahead and distribute our negative 5 times x is negative 5x. And negative 5 times 3 is negative 15. Okay, so we can go ahead and start combining our like terms on this side. Okay, so we have 3x plus 12 equals 12x minus 5x is 7x. And 19 minus 15 is 4, positive 4. All right, so now we just have to bring all of our x terms to one side. So if we subtract 3x from both sides, these two will cancel out. So we end up with 12 equals 7x minus 3x is 4x plus 4. Go ahead and subtract 4 from both sides. 12 minus 4 is 8. So we have 8 equals 4x. So if we divide both sides by 4, we have x equals 2. Or you can write it as x equals 2, doesn't matter. Okay, but remember, you have that fourth step, which you can do just by looking at it in most cases, but we're going to write it out. So you have 3 over x plus 3 equals 12x plus 19 over, instead of x squared plus 7x plus 12, I'm going to make it x plus 4, x plus 3, minus 5 over x plus 4. We can see if we plug in x equals 2, none of those denominators will become 0. Okay, so plugging in x equals 2 will not cause any denominators to equal 0. Okay, so we know that x equals 2 is a valid solution. All right, so we're going to go to one last example. Oh, if you're still writing, feel free to press pause. All right, so let's say, for example, if we want to solve x plus 14 over x minus 2 equals 7x over x minus 2 plus 1. All right. So really here, you don't have a whole lot of factoring that's necessary. You could make 14 into 7 times 2. You don't have to. Okay, so we're going to go ahead and solve this one. So first, no factoring necessary. So we can go ahead and skip the first step. All right. So we're going to go ahead to our second step. Here, we just have one value. Here's a variable value. And we have a whole number value. And we have an x minus 2 in our denominator. So you want to remember that x, that's the same as saying x times x minus 2 over x minus 2. Because we can go ahead and cancel those x minus 2's out and stay with x. And same thing with 1. 1 is just x minus 2 over x minus 2. Okay, so we can make those denominators all match up. Okay, so we will have, instead of x, we'll make it x times x minus 2 over x minus 2. Plus 14 over x minus 2 equals 7x over x minus 2 plus, remember 1 is the same as x minus 2 over x minus 2, so we have x minus 2 over x minus 2. Okay, so just like the previous examples, when all of the denominators on both sides of the equal sign are the same, if you multiply each term by x minus 2, all of your denominators will cancel out. Okay, so if you multiply this one by x minus 2, it'll cancel out. This one by x minus 2, this one by x minus 2, and this one by x minus 2, they all cancel out. Okay, so once you realize that happens each time, you can go through the steps, but you can actually skip that step as long as each term has the same denominator. That's the key. Okay, so you have x times x minus 2 plus 14 equals 7x plus x minus 2. Okay, now since this is positive, you didn't have to write the parentheses here, but I just wrote it anyway, just to create good habits. All right, so we can go ahead and solve, or start to solve here. So we can go ahead and distribute the x here and distribute the 1 there, which is really just dropping the parentheses for that one. Okay, so x times x is x squared. X times negative 2 is negative 2x. Plus 14 equals 7x. 1 times x is x. And 1 times negative 2 is negative 2. Okay, we can go ahead and combine those two. Okay, so we have x squared minus 2x plus 14. 7x plus 1x is 8x minus 2. All right. Now with this one, this is a little bit different because what you want to do now is you want to pull everything to one side. This is why this question is a little trickier, because you have that x squared. You're not just solving for x. Okay, so when you have that x squared, you just want to pull everything. You want to make all of that on one side equal to 0, and I'll show you why. So if we subtract 8x from both sides, you have x squared. Negative 2x minus 8x is negative 10x plus 14 equals negative 2. So if we add 2 to both sides, that gives us x squared minus 10x plus 16 equals 0. Okay. Now because of that x squared, we wanted to pull everything to one side. That's talking the x variable, x terms, and the non-x terms. Okay. Reason is because x squared minus 10x plus 16 can be factored into x minus 8 times x minus 2 equals 0. All right. So that means if we make either one of these 0, it will make this true. That means x minus 8 is 0. So if x is equal to 8, 0 times anything is 0. Same thing here. If we turn this to 0, 0 times whatever this is will be 0. That means x minus 8 can equal 0, or x minus 2 can equal 0. Either one of those can equal 0. So if we add 8 to both sides, you have x equals 8. Move that up some. Or if we add 2 to both sides here, x can equal 2. Okay, so this puts a little bit of a twist on what's valid and what's not. Because we go to our fourth step, we have our x. Remember, you can use the equation here, or you can use the starting equation, doesn't matter. If x plus 14 over x minus 2 equals 7x over x minus 2 plus 1. So if you plug in x equals 8, none of those denominators turn to 0. If you plug in x equals 2, you have denominators that turn into 0. So plugging in x equals 8 will not cause 0, will cause a 0 in any denominator. Probably a better way to say that one. In any denominator. So that means x equals 8 is a valid solution. But we see that plugging in x equals 2 will cause a 0 in a denominator. So x equals 2 is not valid. Okay, you can't use that one. So x equals 8 is the only valid solution. All right. So hopefully these made sense, and I will see you on the next video.